Is Allison Daubert, and I am the teacher in residence for the physics department here at BSU. Before coming to BSU, I was a high school physics teacher, and I loved my job so much that I wanted to come here and help recruit and train and mentor our future pre-service physics teachers. So today we've got a fun physics experiment for you, and I'm going to introduce you to some of our pre-service BSU physics teachers that are going to help us with it.
My name is Caitlin Diver. I'm a second-year student at Bridgewater State University, and I chose a career as a physics teacher in order to help change the lives of our future generations.
My name is Sean Geary. This is my second year at Bridgewater State University, and I want to be a physics teacher because it's fun.
Hi, my name is Ben. I want to be a physics teacher because it's a career with job security and great pay.
So we took a large slingshot and we brought it out front of our Math and Science Center, and we wanted to figure out what the launch velocity was of a small ball out of our slingshot. And so Caitlin and Sean and Ben are going to launch this ball, and we want to figure out the launch velocity with the least amount of equipment available. So when we did this experiment, we had a high-speed camera. It was my iPhone, and we had 2 meter sticks. So that was all we had at the time. So what information would you need to know using that equipment in order to find the launch velocity for the slingshot? So as you watch the video, think about that, and then we'll show you the data that we collected. Okay, so here's the data that we collected when we did this experiment. The first thing that we did was we found the frame rate. So the frame rate for an iPhone 11, if you're shooting in slow motion, is 240 frames per second. This means that each second, there's 240 frames that are shot. The amount of time that this was in the air was 380 frames. So we did that by actually clicking through this video and finding how many times we had to click between when the ball initially leaves and when it hits the ground over here. And so this distance we were able to measure that it travels is 15.6 meters. We were able to measure that with the meter sticks. We didn't have a protractor to get the angle, so instead we had to get a little bit creative. We measured the height between the ground and Caitlin and Sean's hands as being 0.95 meters. And Ben was able to pull it back exactly 1 meter from where Caitlin and Sean were standing. And so what we want you to do is use this information to find the launch velocity of this slingshot. And so the next thing that we want you to do is to think about the assumptions that you need to make to solve this problem. There's a few. And so you can think about how each one of those might affect your answer. And then, taking into account those assumptions, think about whether your calculated answer is likely higher or lower than the true launch velocity, and explain why. And so we had some fun doing this, and we hope that you guys will enjoy solving for the launch velocity for this slingshot.
Hello, I'm Jeff Williams. I'm a physics professor here at Bridgewater State University. We have a really great physics department here, and we have many concentrations that you might be interested in, so please check us out. Our newest one is in photonics engineering, which we're very excited about. Alice and I are working together on training future physics teachers, so especially if you're interested in teaching physics in your future, contact one of us.